BP diol. But this BP epoxide, this intermediate, is extremely reactive. Right? And it turns out most of it reacts with water to form BP diol, which is something that's closer than you can pass in urine. Unfortunately, some part of it can react with a G base in your DNA. So here's your DNA chain, the phosphate sugar. That's the base. It turns out that the NH2 on that can also react with this. And what you end up with, it's on your handout, this big ugly monster down here. You've got your DNA strand, and there's the base. It's supposed to be base pairing. It's got this big thing stuck on it. And this isn't just this isn't some weak hydrogen bond or something. That's an honest-to-God covalent bond there, right? So that's nailed onto that G. That G is particularly now messed up. And it doesn't base pair properly. And you might ask why that's a problem, and I'll show you why that's in a second. But before I talk about why it's a problem, this is how we'll draw it as an abbreviation. G with a solid line there, meaning a covalent bond, and BP attached to it. That's, like I said, a real honest-to-God covalent bond. It's nailed on there and says messed up this base. Before I talk about why that's bad and leads to mutations, everybody with me on sort of what the body is trying to do and how it goes wrong? Questions about that? Okay. So